is 4 to the power 0 is 1. Did you remember that it's 1? So, any any guesses on 4 to the power a half? I hear 9, I hear 8. Anybody? Okay, maybe I should extend this 4 to the power 1 thing. What's 4 to the power 3? 4 to the power 2? 4 to the power 1? 4 to the power 0? 4 to the power a half? It is 2. So what do you think it's going to be? Oh, you think you half it. Okay, let's try it with 16 then. 16 to the power 3 might be too high. 16 squared, you probably know what that is. 256. 16 to the power 1. 16 to the power 0. 16 to the power a half. Oh, we say it's 8. It's 4. How did you get 4 out of that? You guessed. You guessed. It is the square root. Yes, very good. So that's the new thing here. In grade 9 that you learned that powers with integral bases and whole number exponents, a to the power m times a to the power n, what do you do with those two exponents? You add them. So 5 to the power a half times 5 to the power a half is 5 to the power, add them, 1. So you get 5. Look at this. 5, the square root of 5 times the square root of 5 is the square root of 25, which is 5. Yes? Is that not the same thing? So that's the kicker here is 5 to the power half and the square root of 5 are the same, equivalent. I have one word, so it must be equivalent. Raising a number to the exponent a half is equivalent to taking the square root of a number. Equivalent. We can extend this law to fractional exponents with numerator 1. That's where the 1/2 comes from. The numerator is 1. Because we're going to be looking at fractional exponents. What do you think 5 to the power 1/3 would be equivalent to? The cube root. And 5 to the power 1/4, the 4th root, etc., etc. So radicals may be written as numbers with fractional exponents. The square root of 5, which is that, could be written as 5 to the power a half. The 1 represents the exponent or power of 5, because it's 5 to the power 1. That's what this 1 represents. The 2 represents the second power or the square root of 5. So here is the huge kind of take back of all this. X to the power 1 over n, whatever that n is your index of your root. So that's why I was saying the 4th root is to the power 1/4, a 5th root is to the power 1/5, etc., etc. So now we're going to evaluate this without the use of a calculator. So 27 to the power 1/3 would be the same thing as the cube root of 27, which is 3. Yes? The cube root of 1,000, or 1,000 to the power 1/3, is 10. 0.49 to the power a half would be 0.7. Very good. 0.25 to the power of half would be 0.5. Negative 8 to the power 1/3 is negative 2. 16/81 to the power 1/4 would be 2/3. Any questions how we got that? So it's just an extension of what we've been doing, right? Okay, so now for the good stuff. Now, we're going to put double powers together. What we're going to be doing here is we're going to have not just a 1 on top, we're going to have a number on top and a number on the bottom, which means, remember, the number on the bottom is your index of your radical, and then the number on top is what the whole thing to the power is. Now, you can either do the power first, then the root, or the root first, then the power. What do you think is easier to do first? Yeah, the roots first. Why is the root first easier? What does the root make the number do? Make it small. And then if you're going to do to the power 5, that's easy versus a big number to the power 5 and then make it small. So remember that when you're doing this, the order, helps, right? So we have 82 to the power 5/2. So they're just wanting you to write it 2 different ways. They're not expecting you, because 82 is not a nice little thing to do. But anyways, so does everybody see that the 2 is the same thing as a square root of 82 to the power, what? 5. Yes? Oh, they want me to do it the other way because I can see that's what they want there. Let's try this again. That's this answer right here, 82 to the power 5 outside. They want 82 to the power 5 inside there. Oh, that's such a small number. Let's try that again. 82 to the power 5. Sorry if I didn't give you enough space there. Same with the next one. If this is the cube root, and this is 9 to the power 2/3, the cube root represents that denominator there, and the 2 represents the 9 squared inside. Do you see that? Or you could write it as the cube root of 9, the whole thing to the power 2. Are we good with this? Okay. So let's write this now the other way. We're going to start with radical form, and we're going to go into fractional form. Can anybody tell me what this a is to the power? H is to the power, what fraction? Yeah, 5/2. I don't know if I could hear you or not. 5/2? Do you see how I got 5/2? The 5 is the numerator. The square root is an index 2, so that goes as a denominator. Okay, let's try the next one. This is 6 to the power 4/3. Very good. Okay, now we're going to go the other way. 3 to the power 5/2 is the same thing as the square root of 3 to the power 5. Or we could write this as the square root of 3 to the power 5 like that. So although we can't square root 3, it'll make more sense once we get to numbers we can actually square root and cube root. So that's coming up in example 6. So how about this one? This one would be the 5th root. Make sure you put that little 5 to the 25 to the power 2, or I could write this as inside, still a 5th root, 25. Yeah. Okay, we're getting the lingo of this, going back and forth. It's all good? Okay, always evaluate the radical first, then apply the power. Again, the reason why is because you make the expression smaller before you make it bigger. Of course, we're going to start with this here. Holy smokers. Do you know what 0.2 is as a fraction? 1/5. This is the same thing as 32 to the power 1/5. Well, 0.2, if I change it to just read it like normal, it would be 2/10. which reduces to 1/5. Does that make sense to you now? Okay, so what is 32 to the 1/5? It's the 5th root of 32. So what is it? Yeah, 2. 2. Yes? Because 2 to the power 5 is 32, so the 5th root of 32 is 2. Okay, so now we have not a 1 on top this time. Now it's a 3 on top. So remember we said we want to square root 0.01 first, then we're going to do it to the power 3. Always do the radical first, then make it bigger. So what is the square root of 0.01? 0.1, yes? And then what's 0.1 to the power 3? What's 0.1 to the power 3? Point what? 0.001? 1, 2, 3. Right? 1, 2, 3. Yeah. Okay. So how about this one? We're going to write this as the cube root of minus 27 to the power 4. So what's the cube root of minus 27? Is it 3? Minus 3. So minus 3 to the power 4. What's that equal to? Positive 81. Does everybody see how I'm doing this? Well, because if I have an even number of negatives, it's always positive, right? Like 2 negatives is positive, 3 negatives would be negative, 4 negatives would be positive, yes? Okay, let's keep going. 81 to the power 3 over 4. So this would be the 4th root of 81 to the power 3. So what would that be? What's the 4th root of 81? And then 3 cubed is 27. Do you see how fast and easy this is once you get going on it? Nice, eh? Okay, next one. Ooh, this is 1.2. So the first thing we got to do is we got to make it into a fraction here, right? So what's 1.2 as a fraction? 1 and 2 tenths, yes? Which is 1 and 1/5, which is what as an improper fraction? 6 over 5. So that's the first thing. If you see any decimals, you got to change it into a fraction. So this is 0.75 to the power 6 over 5. And then you might say, holy, this is going to be hard to find the 5th root of 0.75. It's what? 15? Which way are you doing? I apologize. There's something wrong with that question. It's not going to work for you, so let's move on. I'll have to fix that for next time. If I were to ask you this and told you to evaluate, it would be something that you could evaluate. You can't find the 5th root is 0.75, so there's something wrong with that number. Anyways, how about this one? This would be the square root of 36 to the power 3. So that would be 6 to the power 3, which hopefully everybody knows. 216. Very good. All right.